Okay, so a couple ways you can find the vertex of a quadratic function. We've already looked at one way where you complete the square to put the function into this form, which is what I prefer because we know how to complete the square, and then you could easily find the vertex. The other way is, much like the quadratic formula, there is a formula to find the vertex of a quadratic function. So if your quadratic function is written in this form, ax squared plus bx plus c, then your vertex of this function is an ordered pair, of course, so the x-coordinate would be negative b over 2a. The y-coordinate is what you get when you plug negative b over 2a into the function, so f of whatever this number is, okay? So this is your vertex formula. You might write it down. So in this function it's in the form ax squared plus bx plus c, so this is a, b is the 1 in front of the x, and c is negative 3. So the vertex, let's call this the x-coordinate of the vertex, so I'll write it like this. The x-coordinate of the vertex is negative b over 2a. Well, that's negative 1 over 2 times a, which is 2, so 2 times 2 is 4. So you've already got your x-coordinate. The y-coordinate of the vertex is what you get when you plug this value, negative 1/4, into the function. So every place I see an x in my function, I'm going to replace now with 1/4. So I have 2 times negative 1/4 squared plus negative 1/4 minus 3. So I have 2 times negative 1/4 squared is 1/16 minus 1/4 minus 3. 2 times 1/16 is 1/8, so we've got 1/8 minus 1/4 minus, and I'm going to put the 3 over 1. Getting common denominators of 8, I would multiply 2 over 2 here and 8 over 8 here. So we end up with 1/8 minus 2/8 minus 3/8. So 1/8, 1 minus 2 is negative 1 minus 24, sorry. 1 minus 2 is negative 1 minus 24 is negative 25 all over 8. So that is the y-coordinate of the vertex. Therefore, the vertex is the ordered pair negative 1/4, comma, negative 25/8.
Alright, the original author makes a small mistake here, so guess what? I get to jump in. Alright, so we're going to find the vertex of the function f here, which is x squared minus 2x, and look at, there's nothing on the end here. So this just shows that there is an a, b, and a c still, because my c is plus 0. So here we have the a is 1, the b is negative 2, and the c is 0. So we can still find the vertex. Remember, it's the opposite, or minus b over 2a, comma, the f of minus b over 2a. Alright, now I just do the same things as he did before. We take the opposite of b. Well, here the mistake that he made was the opposite of negative 2 is positive 2, right? Because you have a minus and then you have a negative 2. So the opposite of negative 2, and then over 2a, 2 times 1. So this is the x value of the vertex. This becomes positive 2 over 2, which is 1. So my x value of the vertex is 1. Alright, that's pretty easy, because now we just put it back in there to find the y value. So stick it right back into the function. F of, let's change the color here, let's go f of 1, right, goes in, and then everywhere I see an x, I want to write a 1. So I have 1 squared minus 2 times 1. So I'm putting my 1's in there. So it's f of 1 equals 1 squared minus 2 times 1 plus 0. So everywhere that I saw an x, see x and x, I replaced it with a 1. 1, 1, 1. So f of 1 is 1 minus 2. F of 1 is equal to negative 1. So my vertex of this parabola, of this quadratic function, is 1, negative 1. I pulled up the graph of this function on the grapher. If you see that x squared minus 2x, put it into here, you can see that here's the parabola it produces. Now look at where the vertex is, 1, -1, which is right there. So this does work.